Here's another example of solving systems of equations by substitution. And we've got two equations, 3x minus 4y equals 10 and 2y plus 4x equals 6. So again, we want to be able to take one of the equations and solve it for either x or y. And we pick the one that's easier. And I notice that 2, 4, and 6 are all divisible by 2, so I think it might be easier for me to solve for y, because y is a little smaller. 3 doesn't go into 10, so that's kind of an odd fraction. I could do it, but it would be a little bit more complicated. So I want to avoid, dealing with fractions as much as I can. So let's try number 2. So let's take equation number 2 and let's solve that for y. So I would subtract 4x from both sides. So I got 2y equals 6 minus 4x. And if I divide everything by 2, y would equal, and 2 goes into 2 once, 2 goes into 6 3 times, and 2 goes into 4 twice, so 2x. So that works out pretty good. Now we've got y in terms of x. So now we'll take equation, now we'll put that in, we'll substitute that into equation number 1. So I'll write equation number 1 here. And every time I see a y, I'll put 3 minus 2x. So 3x minus 4 times y, that equals 10. But what was y? Y is 3 minus 2x, so we substituted. Okay, this is y, 4y. Okay, and then I've got one equation with one unknown. Remember, we really can't solve two equations with two unknowns, but what we can do is we can algebraically manipulate them around, so we have one equation with one unknown, and we know how to solve that. We're experts in one equation with one unknown. So we've got 3x, and I use the distributive property. That's going to be negative. 4 times 3 is negative 12. A negative times a negative is positive. 4 times 2 is 8x. That equals 10. And then 8 plus 3 is 11, so I'll combine my x's. So I've got 11x minus 12 equals 10. And then I'll add 12 to both sides. And I end up with 11x equals, and 10 plus 12 is 22. And then if I divide both sides by 11, x equals 2. Well, that's nice. Now if I want to find out what y is, I know that y equals, and that's from equation number 2, y equals 3 minus 2 times x. And what's x? X is 2. So y equals 3 minus 4, negative 2 times negative 2 is a negative 4, and that equals a negative 1. So there's my solution, and I could write it as a point because it's a value that satisfies both these. So sometimes we can write the solution as a solution set, and that point's going to be 2, negative 1. Or we could write it just as x equals 2 and y equals negative 1. All right? So there's another good example of substitution. Oops. And again, you can check that out. Hope that helps.